The long arc of better making. From Sheng to Henry Ford, engineering, standardization, and the ethics of manufacturing. Introduction. The history of human progress is, in no small part, the history of making things better, not just better in the sense of more capable or more profitable, but better in the deeper sense, more reliable, more honest, more worthy of the people who use them. That thread runs from Sheng's invention of movable type in 11th century China, which democratized the written word, forward through centuries of craft and invention, and arrives, with particular force, at the figure of Henry Ford and the revolution he set in motion on the factory floors of early 20th century America. Ford is often remembered as the man who put America on wheels. That is true enough, but it understates the real nature of his contribution. What Ford and his engineers accomplished was not merely the production of automobiles at scale. It was the deliberate, systematic application of engineering principles to manufacturing itself. They asked not only how to build a car, but how to build the process of building a car. In doing so, they transformed what manufacturing could be and, more importantly, what it should aspire to be. At the heart of that transformation was a conviction that runs counter to a great deal of conventional business thinking. Then and now, Ford believed that the purpose of engineering was to solve problems permanently, not to create the appearance of solutions that would need to be replaced, updated, or repurchased. He believed that a well-made part should fit every version of the machine it was designed for, that customers deserved products that could be maintained and repaired, and that the measure of good manufacturing was not the size of next quarter's order book but the lasting usefulness of what you put into the world. A philosophy of efficiency. Ford articulated this philosophy with characteristic directness in his 1922 autobiography, My Life and Work. In a passage that reads as freshly today as it did a century ago, he described the prevailing industry practice of his time, and of ours, and found it lacking. It is considered good manufacturing practice and not bad ethics occasionally to change designs so that old models will become obsolete and new ones will have to be bought either because repair parts for the old cannot be had, or because the new model offers a new sales argument which can be used to persuade a consumer to scrap what he has and buy something new. We have been told that this is good business, that it is clever business. Our principle of business is precisely to the contrary. The parts of a specific model are not only interchangeable with all other cars of that model, but they are interchangeable with similar parts on all the cars that we have turned out. Henry Ford and Samuel Crowther, My Life and Work. These two paragraphs contain, in compressed form, one of the most important ideas in the history of industrial manufacturing. Ford is not simply making a business argument. He is making an ethical one. The deliberate engineering of obsolescence, such as periodically redesigning components to not be interchangeable with previous designs with no plausible, legitimate business rationale.
Interchangeability, the engineering principle behind the philosophy. The specific practice Ford described, interchangeable parts across all models of a vehicle and even across successive generations of vehicles, was not a new idea in 1922. Its roots reach back to the late 18th century, when French gunsmith Honoré Blanc demonstrated muskets assembled from randomly selected, pre-fitted parts. American manufacturers, particularly in the armaments industry, had pursued what came to be called the American system of manufacturing through the 1800s, developing precision machine tools capable of producing components to tolerances tight enough that one part could substitute for another without hand fitting. What Ford did was extend this principle to its logical conclusion in a consumer product of enormous complexity, and then hold to it as a matter of policy across the entire life of the product line. A replacement part for a 1909 Model T would fit a 1920 Model T. An owner in rural Kansas, far from any dealership, could order a component and be confident it would work. This was not an accident of design. It was the result of deliberate engineering discipline, of resisting the temptation to improve the interface in ways that would benefit the factory's order book at the expense of the customer's investment. That discipline requires something that is harder to maintain than it might appear: the willingness to subordinate short-term commercial advantage to long-term engineering integrity. Every time a design change is proposed, the question must be asked: does this change make the product genuinely better, or does it merely make the old product obsolete? Ford's answer was that only the former justified a change. A thread running forward. This document is part of a larger inquiry that began with by Sheng and the invention of movable type, a technology whose significance lay not only in what it could produce, but in the principle it embodied, that a carefully designed, reusable, standardized component could multiply human capability far beyond what bespoke craftsmanship alone could achieve. The broader significance, manufacturing as engineering, not just commerce. The implications of Ford's philosophy extend well beyond the automobile industry. What he was describing, at its core, was the proper role of engineering and manufacturing, not as a servant of sales cycles, but as a discipline with its own standards, its own integrity, and its own obligations to the people who depend on the products it produces. Standard engineering practices, consistent tolerances, documented specifications, modular and interchangeable design, rigorous testing, exist for reasons that are fundamentally about reliability and human benefit. When those practices are compromised for commercial reasons, the cost is borne not by the manufacturer, but by the user. The farmer whose tractor fails a harvest, the mechanic who cannot obtain a part, the family whose vehicle becomes worthless because a replacement component is no longer available. Ford understood this. The assembly line and the moving conveyor, the innovations for which he is most famous, were means to an end. The end was a product that was genuinely affordable, genuinely reliable, and genuinely maintainable by the people who bought it. The efficiency of the manufacturing process served the integrity of the product, not the other way around. Henry Ford was, in a meaningful sense, working in the same tradition. The individual type sorts of by Sheng's press and the individual components of a Model T are separated by 9 centuries and enormous differences in scale and complexity. But both rest on the same foundation, the idea that thoughtful, disciplined engineering that designs for reuse, for interchangeability, for the long-term benefit of the user, is more valuable than clever engineering that serves only the immediate interests of the maker. What follows in this work will trace that thread further, examining how the principles Ford articulated have been honored, abandoned, and rediscovered across different industries and eras, and what the consequences have been in each case. The story is not simply one of technological progress. It is a story about what manufacturing is for and who it is supposed to serve. Ford's words from 1922 offer as clear a statement of the right answer as any that has been written. The challenge, as it has always been, is in the doing.